Hi, this is KK sir. Now we are going to learn about square, its properties and theorems related to the square. First of all, definition. So definition of the square is, see here, a parallelogram in which all sides are equal. First of all, I'm saying it's a parallelogram because square, rectangle, rhombus, these are all parallelogram. They will belong to the family of parallelogram. So a parallelogram in which all sides are equal. The condition is all sides should be equal and each angle is 90 degrees. Every angle should be 90 degrees. Then that parallelogram is called a square. Such type of parallelogram is nothing but called as square. Note, most important thing, a square is a rectangle because a square holds all the properties of the rectangle. Whatever the rectangle properties are there, all the properties are held by square. That's why a square is a rectangle. Now coming to the properties of squares. First one, it holds all the properties of the parallelogram. Whatever the parallelogram properties are there, four properties. What are the four properties? Opposite sides are equal, opposite angles are equal, diagonals bisect each other, adjacent angles are supplementary. Those all properties are held by the square. Next, additional to that, we have four more properties, are five more properties, okay, right? All angles are 90 degrees each. So each angle, four angles are there, each angle will be 90 degrees and all sides are equal. All sides are equal. All the four sides will be equal. This is most important. All sides are equal and each angle is 90 degrees. This is the additional property which square has. Next, diagonals are perpendicular to each other. That means if you see here, this is a square. This is a square ABCD. If this ABCD is a square, then all the four sides will be equal. Okay, right? All the four sides will be equal. Each angle is 90 degrees. Each angle is 90 degrees. Every angle is 90 degrees. And diagonals bisect each other already. Okay, right? Why diagonals bisect each other? OA equals to OC, OB equal to OD, because it is parallelogram. A square is a parallelogram. In parallelogram, diagonals bisect each other. So in square also, diagonals bisect each other. This part is equal to this one, this part is equal to this one. So diagonals bisect each other. Okay, right? Diagonals bisect each other. Next, the most important is the diagonals are perpendicular to each other. Perpendicular to each other. That means this diagonal and this diagonal are perpendicular. That means the angle between these two diagonals here is 90 degrees. So even this angle also will be 90 degrees. This will be 90 degrees. This also will be 90 degrees. Each angle will be 90 degrees. Okay, right here. So diagonals will be perpendicular to each other. This diagonal will be perpendicular to this diagonal and they bisect each other also. Next, diagonals are equal. Diagonals are equal. This diagonal length, AC length, will be equal to BD length. Diagonals are equal. And AC is perpendicular to BD. Both are perpendicular to each other. Next, diagonals bisect opposite angles. That means in square, if this is a square, ABCD is a square, this is angle A, angle C. This you already know angle A is 90. Angle C is also 90. So this diagonal, what it makes is, it bisects the opposite angles. That means this is divided into 45, 45. This also bisect is 45, 45. So this diagonal bisect the opposite angles. Okay, right? Bisect the opposite. Similarly, this diagonal also bisect the opposite angles. This opposite angles, okay, right? 90. It is divided into 45, 45, 45, 45. So diagonals bisect each other. Okay, right? Diagonals bisect each other. Diagonals bisect the opposite angles. Diagonals are perpendicular to each other. Mostly, completely with the diagonals it will be there. Okay, right? Diagonals are equal. Diagonals are perpendicular. Diagonals bisect each other. Okay, this is all the related to diagonals. So these are the properties of the square. Let us recap it. All the properties of the parallelogram. It holds. All angles are 90 degrees each and all sides are equal. All sides are equal. This is most important. Diagonals are perpendicular to each other. Diagonals are equal and diagonals bisect opposite. These are the properties of the squares. Now we are going to discuss some theorems related to squares. Okay, right? Two theorems are there. We are going to discuss those two theorems now. Okay, right? Theorems related to squares. Okay, right? First theorem. Prove that a parallelogram, that means he's giving you a parallelogram in which diagonals are equal and intersect at right angles. Intersect at right angles is a square. Okay, right? Is a square. So what he has given? He has given a parallelogram. This is a parallelogram, not square. It is a parallelogram. First initial, we have to prove it is a square. It is a parallelogram in which diagonals are equal. This AC diagonal and this BD diagonal are equal. These two diagonals are equal and they are intersecting at where they are intersecting at right angles. That means at 90 degrees they are intersecting with the 90 degrees. The angle here, let us suppose O, this angle is 90 degrees. If this is 90, automatically this also will be 90. This part also 90. This also 90 degrees. All these four angles will be 90 degrees each. Okay, right? What is he saying? These diagonals are equal. That means ABCD is a parallelogram he has given to us. What is given in this theorem? ABCD is a parallelogram. And he said that AC is equals to BD. The diagonal AC and diagonal BD are equal. And he said that the diagonals are perpendicular. That means here the angle AOB, that is angle AOB is equals to 90 degrees. Not only AOB, this angle is 90, this angle is 90, this angle is also 90. All the here four angles are 90 degrees each. Now we have to prove ABCD is a square. We have to prove ABCD is a square. To prove this is a square, to prove square, the most important thing is all sides should be equal. All the four sides should be equal and each angle should be 90 degrees. Then it becomes a square. Okay, right? So now we have to prove indirectly ABCD square means we have to prove all sides are equal and each angle is 90 degrees. That is what we have to prove. First I will prove all sides are equal. First I will prove all sides are equal. Okay, right? He said it is a parallelogram. He said that ABCD is a parallelogram. Parallelogram means opposite sides are equal, opposite angles are equal, diagonals bisect each other, adjacent angles are supplementary. Those all four properties I can use here because he said that ABCD is a parallelogram. Now to prove, first I will prove all the four sides equal. Then I will prove all the four angles are equal to 90 degrees. Then I can say that it is a square. So to prove this all angles, no need to prove all angles. If I prove one angle is 90, so automatically all other angles also becomes 90 degrees. Okay, right? A parallelogram in which one angle is 90, all other the four angles also becomes 90 degrees. That is the way we are going to do. Okay, right? Now coming to the proof. Okay, let us prove it. Let us prove this one. Okay, right? Now to prove this one, first I will take these adjacent triangles, these two triangles. I will take this AOB triangle and BOC triangle. These two triangles I will take. So what we'll do is in these two triangles, this side we can't speak anything about this side. This is the common side for both the triangles. OA is equals to OC. OA is equals to OC because since parallelogram diagonals bisect each other. Because diagonals bisect each other, OA part will be equal to OC part. Okay, right? Diagonals bisect each other. This is the common side. OB is equals to OB. Okay, right? Common side. And this angle is 90. This angle is also 90. Angle AOB is equals to angle angle OCB. COB. These two angles bracket since diagonals are perpendicular, so that angle will be 90 degrees. This is common side. So if you see this one, OA side, this angle and this side, so that is nothing but SAS. This is side, this is angle, this is one side, this is one angle, and this is another side. By SAS I can say that triangle AOB is congruent to triangle COB. These two triangles are congruent. These two triangles are congruent. By CPCT, I can say that by corresponding parts, I can say that AB part is equals to BC part. Therefore, AB is equals to BC. By CPCT, AB is equals to BC. But AB is equals to CD. But already AB is equals to BC. But AB is equals to this AB part. This AB part is equals to CD because opposite sides of the parallelogram are always equal. He has given that ABCD is a parallelogram. So opposite sides are equal. AB is equals to this AB side is equals to CD side. And this BC side is equals to AD side. BC is equals to AD. So all four sides are equal. All sides are equal. All sides are equal. Okay, right? Why this is one? Since opposite angles, since parallelogram. Because parallelogram opposite sides are equal. So AB is equals to CD and BC is equals to AD. So automatically all the four sides will be equal. All sides are equal. So all sides are equal is not enough. All sides are equal will be in the rhombus also. So we have to prove some extra here. Each angle should be 90 degrees. Now let us prove each angle is 90 degrees so that it becomes a square. Now to prove that one, okay, right, to prove that one, what I will do is, to prove each angle is 90 degrees, what I will do is, I will take the two triangles where the diagonals are there. I will take this triangle ACB. This is part 1. I can say this is part 1. I can say this is part 2. Part 2. This is part 2. I should prove that all angles are 90 degrees. To prove that one, I will take this triangle ACB and triangle ACB and another triangle ADB. This triangle and triangle ADB. So draw them separately for your convenience. So this is ACB triangle and this is ADB triangle. In these two triangles, AB is equals to AB. This is the common side. AB is equals to AB, common side. Common side. Okay, right? And BC is equals to AD. BC is equals to AD. Bracket, since opposite sides of parallelogram. Opposite sides of parallelogram. Okay, right. And next, already he has given in the question that, in the proof, okay, right, he has given already question that AC is equals to BD. He said that already diagonals are equal. So we can use AC is equals to BD. Bracket, since diagonals are equal. Therefore, S rule, therefore by SSS rule, by SSS I can say that triangle ABC is congruent to triangle ABC is congruent to triangle BAD. These two triangles are congruent. By CPCT I can say that angle in this triangle, angle A is equal to in this triangle angle B. These two are corresponding parts. So angle A is equals to angle B. Okay, right? When you go to the main figure, what is angle A? This is complete angle A in this triangle. BTA, angle A, and ACB triangle, angle B. Okay, right? So these two are nothing but adjacent angles. Okay, right? These two are nothing but adjacent angles of this parallelogram. Now angle A plus angle B is equals to 180 degrees. Bracket, since they are adjacent angles That implies angle A plus angle A is equals to 180 degrees, because these two are equal. In the place of angle A, I can replace with angle. In the place of angle B, I can replace with angle A. So 2 angle A is equals to 180. That implies angle A is equals to 90 degrees. So we got angle A is equals to 90 degrees. A parallelogram in which one angle is 90 degrees, then all angles are also 90 degrees each. Therefore, angle A is equals to angle B is equals to angle C is equals to angle D is equals to 90 degrees. So here we already got all the four sides equal. Now we got all angles are equal to 90 degrees. Therefore, I can say that ABCD is a square. This is your theorem 1 related to square. So square, to prove it is a square, we need to prove two things. All the sides should be equal and all the angles should be equal. Then only we can say that it is a square. So this is theorem 1 related to squares. Next, theorem 2. We are going to discuss theorem 2 now. What is theorem 2? Prove that in a square diagonals are equal and perpendicular. We have to prove in a square diagonals are equal and perpendicular. We need to prove events are perpendicular. Okay, right? So how to prove this one? So what he has given ABCD is a square. Now let us draw a square for our to prove this one. Okay, right? ABCD is a square. A, B, C, D is a square. This is a square. So in which diagonals are equal? So he said that diagonals are equal. So no, ABCD is a square. We need to prove diagonals are equal. We have to prove this diagonal is equal to this diagonal. We have to prove these diagonals are equal. Okay, right? And we also prove the diagonals are perpendicular. We need to prove that diagonals are perpendicular. That means we have to prove this here, this angle. If I prove one angle is 90, it's enough. Angle AOB is 90 degrees. If I prove this angle is 90 degrees, AOB 90 degrees, that means diagonals are perpendicular to each other. So let us prove this one. To prove this one, because we need to prove diagonals are equal, now let us take the two triangles where diagonals are there. So in triangle where diagonals are there, I will take this triangle ACB triangle, and I will take ADB triangle, these two triangles. Draw them separately if you want. This is ADB and this is ACB. These are the two triangles. In this, AB is the common side. AB is equals to AB. This is the common side. Because he has given it is a square, all sides are equal. All the four sides are equal. So I can say these two sides are equal. AD is equals to BC, bracket, all sides of square. Next, because it is a square, each angle is 90 degrees. This angle is 90, this angle is 90. This angle is 90, this angle is 90. Angle A is equals to angle B is equals to 90 degrees here. So we can say this is DAB. DAB is equals to angle CBA. Both of them are equal to 90 degrees each, bracket. Since each angle of square, because he has given it is a square, we are using this one. Because he has given ABCD is a square. Okay, right? So therefore, by side angle side axiom, these two are equal. This side is equal to this side, and this is the angle. So by SAS, I can say that triangle DAB is congruent to triangle CBA. These two triangles are congruent. Therefore, by CPCT, I can say that AC is equals to BD. By CPCT I can see that AB is equals to BD. This is one thing which is proved. Okay, right? He said that we need to prove diagonals are equal. We need to prove diagonals are equal. Required to prove is diagonals should be equal. So we prove diagonals are equal. The second thing is we have to prove that diagonals are perpendicular. We have to prove that angle AOB is 90 degrees. To prove this diagonal is perpendicular, we have to prove this angle is 90 degrees, or we can prove this angle is also COB is also 90 degrees. To prove that one, what I will do is I will take these two triangles. These two triangles. In triangle AOB, in triangle AOB and triangle COB. In these two triangles, OA is equals to OC. OA equals to OC. OA equals to OC. Next, AB is equals to BC, because their all sides are equal. AB is equals to BC. This is since diagonals bisect each other, and this is since all sides of square and this is the common side. This is the common side. OB is the common side. Okay, right, in these two triangles, common side. Therefore, by S, I can say that triangle AOB is congruent to triangle COB. This triangle is congruent to these two triangles. By CPCT, I can say that this angle is equals to this angle. By CPCT, I can say that angle AOB is equals to angle COB. These two angles are equal. Okay, these two angles are equal. So if this is X, this also will become X. Okay, right, now both of them, let I will think this angle AOB is equals to angle COB is equals to X. Now these two makes here this angle AOB and the COB, these two angles make straight line angle. So angle AOB plus angle COB is equals to 180 degrees. Bracket, since linear pair. That implies x plus x is equals to 180 degrees. That implies 2x is equals to 180 degrees. That implies x is equals to 90 degrees. Therefore, angle AOB is equals to COB is equals to 90 degrees. That means this angle is 90, this angle is 90. Therefore I can say that AB, the diagonals AC diagonal is perpendicular to BD diagonal. Hence proved. So he asked us to prove two things here. Diagonals are equal. We proved diagonals are equal here, and he has asked us to prove diagonals are perpendicular. We have proved diagonals are perpendicular. Hence proved. So these are the theorems related to squares. Thank you.